Hello all, welcome to the Countingwell exam prep live session. Before we start the session, let me give you one secret of success. So the secret is that your success is determined by your hard work and strong focus on your goal. We know that exams are near, the books are ready, but something is missing. What? Our eagerness to study. That means practice and revision, right? So we are here to help you revise your concepts. Stay tuned to the session and build up the confidence to face your exams. In this session, I will take you through two chapters, Factorization and Mensuration. Let us see some basics from the chapter Factorization. What is factorization? It is nothing but a process of expressing a number or a term as a product of its factors. Let us see how to factorize using method of common factor. Let us factorize 3p square q plus 3q. So the first step is to factorize each term of the expression. So here we can see one algebraic expression in terms of two variables p and q, where the constant here is 3. Step 1 is to factorize each of the terms of the expression. So here the first term is 3p square q. So it is nothing but 3 times p into q, whereas 3q is nothing but 3 times q. Let us see the next step. Here we are going to find the common factor of the terms. You can see the common factors are, for both the terms are 3 and q. So 3q is the common factor. Now we write the product of the factors by taking out the common factor. So if you take out 3q as common from both the terms, here you will get p into p, which is p square. And for the second expression, we don't have anything common. It means we have common 1. And here we have p into p, that is p square. So we have 3q into p square plus 1. So in this way, we are factorizing using the method of common factor, that is taking the common factor out from the expression terms. Let us see how to factorize by regrouping. For example, here we have an algebraic expression having variables a, b, c. We should regroup the terms such that at least two terms have a common factor. So here you can see how many terms are there. 1, 2, 3, 4. There are 4 terms. So we will group in pairs such that one pair will have at least 2 terms common. So here you can see we are pairing 5ab minus 15c in one bracket and 6a square b cube minus 18ab square c in the other bracket. So here we can see we can factorize each group by taking out the common factor. Here what will be the common factor? Among the variables we cannot see any common, but among the constants we can see. Here it is nothing but 5 into a into b. Here we have 5 into 3 into c. Here we can see it is 15c. So it is nothing but 5 into 3 into c. That's why we'll have 5 common. And in the bracket we'll have ab minus 3c. As I told you, it will be 5 into 3 into c. That's why we have 5 common for the first bracket. For the second bracket, we have 6a square b cube minus 18 is nothing but 6 3s are. So we have 6 as common among the constants. For the variables, we have here 2 times a, and here we have 1 time, or else I'll show you how it is. Here we have 2 times a. Here we have 1 time a. So 1a can be taken as common. Here we have 3 times b. Here we have 2 times b. So max to max 2 times b we can take common. We don't have c for 6a square b cube. So we are not taking any terms of c here. So we have 6ab square into ab minus 3c. That's why now we are writing the product of the factors by taking out the common factor. So how we'll write? We'll write it as 5 plus 6ab square, and here you can see these two brackets are same. We'll write it once. So here we have ab minus 3c, and the rest two terms we can see 5 plus 6ab square. So this is factorization by regrouping. Next we will see factorization using identities. So there are identities a square plus b square plus 2ab, which is a plus b square. Then we have a square minus b square. So here you can see we have a square plus 2ab plus b square. A square plus b square plus 2ab is nothing but a plus b square. A square minus b square is nothing but a plus b into a minus b. A square plus b square minus 2ab is nothing but a minus b whole square. And here we have a square plus a plus b into x plus ab, which is x plus a into x plus b. Okay. So let us see how to apply these identities. So here we have a plus b whole square. That means first term square plus second term square plus 2 times the product of the two terms. So here we have y square plus 9 plus 6y. So here you can see y square plus 9 can be written as 3 square and 6y can be written as 2 into 3 into y. So we have y plus 3 into y plus 3, that is y plus 3 whole square as a factorization. Now let us apply this identity. We have one term square plus other term square minus 2 times the product of the two terms. So here you can see it is a square plus 2 square minus 2 into a. Okay, so here we have a minus 2 into a minus 2 as a factorization. Now let us see for a square minus 4, it is nothing but a square minus 2 square. So it is of the form a square minus b square. That's why it can be written as a minus 2, a plus 2. Here the value of b is 2 and a is as it is. Now let us see how can we use this identity. Whenever you have expression where you are taking the square of one term, then the addition of two terms a plus b and then product of that bracket into that variable x plus a into b, you will use this identity. So here we have y square plus 8y plus 15. So you can use it as y plus 3 into y plus 5. Now let us see the division of algebraic expression. Here you can see the names monomial, polynomial, trinomial, etc. So what is a monomial? Monomial is an algebraic expression having only one term, whereas trinomial is an algebraic expression having three terms. What about binomial? Binomial is an algebraic expression having two terms. So whenever we are dividing a monomial by a monomial, means an algebraic expression having one term divided by algebraic expression having one term. So we are cancelling out the common factors. Here you can see phi a xy is nothing but phi into a into x into y, whereas phi into a is phi into a. So for both the terms, we have phi a as a common factor that will get cancelled out, and so we have here xy. Okay. Then we have trinomial by trinomial. For that, we have to factorize both the polynomials and then cancel out the common terms. So the factorization can be done by two methods, as we have seen. One is by regrouping, one is by, or you can use algebraic identities, or you can make it simple by taking out the common factors as well. So here one method is given to divide a polynomial by monomial. We'll take out the common factors of all the terms and then we'll cancel the like terms of the dividend and the divisor. For example, here we have a polynomial 3ab plus 6ac and 3a is a monomial. So among these two terms, 3ab plus 6ac, you can see 6ac can be written as 3 into 2 into a into c. Note that a is common among these two terms and 3 constantly is common. So we have 3a common, which will be outside the bracket, and inside the bracket will have b plus 2c divided by 3a. So we have b plus 2c because 3a is the common factor, will get cancelled and will get b plus 2c. One more method is to divide each term of the polynomial by the monomial. So here you can see the first term is 4abc, will divide by 2c. Then we have 6ac, we divide by 2c. We cancel out the common terms. So here you can see c will get cancelled out. Okay. c will get cancelled out. We'll cancel out one more factor, which is 2. So we have here 2ab. Here you can see c is common. Again we have 2 3s are 6. So we have here 3a. So this is the final answer. Let us see what is value of algebraic expression. The value of algebraic expression is nothing but the value of variable when we put or substitute that variable by that value, will get the resulting answer without any variable. Okay, it will be a constant or fixed value for that particular value of variable. So finding the value of expression by substituting the value of variable is nothing but to find the value of algebraic expression. For example, to find the value of 5a minus 7, we are substituting a equals to 5. So we have 5a is nothing but 5 into a. So we have 5 into 5 minus 7. 25 minus 7, which is equal to 18. So this is the value of the expression 5a minus 7 when a is equal to 5. Let us see some basics from the chapter mensuration. Mensuration is nothing but the field of study which deals with the measurement of perimeter, area, volume of geometric shapes. Perimeter is nothing but measure of the length of the boundary of any shape, and units are centimeter, meter, feet or inches. Whereas area is the space enclosed by the boundary of any closed shape, and the units are centimeter square, meter square, square feet, square inches, etc. Whereas volume is the amount occupied of a space by an object, is the volume. Units of measurements are centimeter cube, meter cube or cubic feet, etc. So whenever you are dealing with the perimeter, area or volume of any geometrical shape, for example, of a cone, of a circle, of a rectangle, then we are dealing with mensuration or the measurements of the geometrical shapes. So perimeter of any closed shape, for example, we have a circle. So perimeter of a circle is nothing but the circumference of circle. If we talk about area of a circle, it will be the space enclosed by the boundary of the circle. Whereas volume we find for 3D shapes. Let us see some perimeters of closed shapes such as rectangle, square and regular polygon. Let us see perimeter of a rectangle. It is nothing but 2 times of length plus breadth. So here, for example, we have length of rectangle is 10 centimeter, breadth is 5 centimeter. Perimeter will substitute length by 10 and breadth by 5 centimeter. So we'll get 2 times 10 plus 5, which is 15. So 15 twos are, we have 30. To find perimeter of square, it is nothing but the sum of the all the sides of the square. So we have 4 times side, and the length of each side, if it is 6 centimeter, we have 4 times 6, which is 24 centimeter. Next, we have perimeter of a regular polygon. Regular polygon has all the sides equal and all the angles equal. But whenever we are dealing with perimeter, we are dealing with the lengths of its sides. So perimeter is nothing but number of sides multiplied by length of each side. So here we have an equilateral triangle having length of each side as 4 centimeter. So perimeter will be 3 times 4, which is 12 centimeter. Next, we have one pentagon having length of each side as 4 centimeter. So we have 5 into 4, which is 20 centimeter. Let us see area of a rectangle and a square. Area is nothing but the space enclosed by any closed figure. So here we are going to find the area of the rectangle. Means you can see the shaded part. It is measured in square, centimeter, square meter, and so on. So area of a rectangle is nothing but length into breadth. Here the length is 12 centimeter, breadth is 5 centimeter. So we have 12 5 is 60 square centimeter. The unit used for area or perimeter is very important. You cannot use here only centimeter or centimeter cube. You have to use centimeter square or square centimeter. Let us see what is area of square. Area of square is nothing but side into side. So here if you have length of each side of this square as 6 centimeter, its area is 6 into 6, 36 square centimeter. Let us see what is area of a trapezium. Area of a trapezium. So what is a trapezium? It is a quadrilateral having only one pair of opposite sides parallel. So the area of trapezium here having height h. H is nothing but the distance between the parallel sides. So it is nothing but half into sum of parallel sides into height. So let us find the area of the trapezium given here. Here height is 12 centimeter and the parallel sides have length 20 centimeter and 14 centimeter respectively. So we'll substitute the given values here. So 14 plus 20 into 12. So we have half into 34 into 12, which is 204 square centimeter. Let us see what is area of any quadrilateral. As here you can see, here it is a random quadrilateral. So it is not a specific trapezium or kite or etc. So in this case, you can see a quadrilateral ABCD where the heights are given. So here the area is found by using the formula half into D into H1 plus H2, where D is nothing but the diagonal. Here you can see AC is the diagonal of quadrilateral ABCD. Note that a diagonal is formed by joining the non-consecutive vertices, where H1 and H2 are the heights of the two triangles formed by the diagonal. Here you can observe ADC and BCA or ABC are the two triangles formed by the diagonal AC of quadrilateral ABCD. So here the diagonal, if it is 24 centimeter, heights are 8 and 7 centimeter respectively. We'll substitute the values here and we'll find the area of quadrilateral ABCD. So it is nothing but half into 24 into 8 plus 7. You need to be careful while you're doing calculation. You have to evaluate the terms inside the bracket and then you have to do the multiplication. So we have 12 into 15, which is 180 square centimeter. Next, let us see what is area of a rhombus. So it is nothing but half into D1 into D2, where D1 and D2 are the diagonals of the rhombus. So if the lengths of the diagonals of the rhombus are given, then we can calculate the area of the rhombus. For example, here the diagonals given are of lengths 13 centimeter, 9 centimeter respectively. So half into d1 into d2 is nothing but half into 13 into 9, which is 58.5 centimeters square. Let us see what is area of a polygon. To find the area of any polygon, we have to split the given polynomials into the shapes whose areas can be found out. For example, we can split it into rectangle, square, or triangles. And then we can find the area of each shape using the formula, and we can add these areas of each part to get the area of the overall polygon. So here you can see a polygon ABCDE split into some shapes. Here you can see ABCD and AED, whereas AED is a triangle. Let us see how to find surface area of a cube, cuboid, and cylinder. Let us find surface area of a cube having length of each side as A. So total surface area is 6A square. Lateral surface area is 4A square. If side of a cube is A equal to 3 centimeter, then we have total surface area as 54 centimeters square, where lateral surface area is 36 centimeters square. Note the difference between lateral and total surface area. Total surface area is nothing but found by adding the areas of all the faces of cube, whereas lateral is by avoiding the two faces, the above face and the below face of the cube. You can see each face of a cube is in the form of a square, or it is a square shape. And if the square has each side of length A units, then its area is A square. Since the cube has 6 faces, we have 6A square as a total surface area. And since for lateral surface area, we are avoiding the faces top and below for this cube. So we have 4 times A square. Let us see formula for the surface area of a cuboid. So here you can see a cuboid has a length, breadth, and height. So this is the length, this will be the breadth, and this will be the height. Total surface area is 2 times length into breadth plus breadth into height plus length into height. Whereas the lateral surface area is 2 times height, length plus breadth. So let us consider a cuboid having length, breadth, and height given here, 4 centimeter, 3 centimeter, 2 centimeter respectively. If you substitute these values, then you will get the total surface area using the appropriate formula given here, and the lateral surface area using the formula given here. Let us see how to find surface area of a cube, cuboid, and cylinder. We have seen cube and cuboid. Let us see for cylinder. The curved surface area of a cylinder, then we have total surface area. What is curved surface area of a cylinder? It is area of the rectangle, which is breadth into length. So here you can see a cylinder having radius r. Radius you can see for the circular shapes. These are the parts of cylinder, and here you can see height h. If we cut this cylinder along this line and open it, you can see this curved surface will become a rectangle, and the length of this rectangle will become 2 pi r because it is nothing but the circumference of the circle, and the height will remain h. That's why the curved surface area of cylinder is nothing but h into 2 pi r, which is 2 pi rh. So the curved surface area is nothing but it is the area found by avoiding these two faces of the cylinder. Okay, these two surfaces, these circular shapes. Let us see what is total surface area. It is found by adding the curved surface area and 2 times the area of the circles. As I told you, these are the two circular shapes. So we are going to add 2 times the area of circles. As we have curved surface area 2 pi r h and the area of circle as r square. That's why we have 2 pi r into r plus h. Let us see how to find total surface area of a cylinder by using the given formula. We know that total surface area is 2 pi r plus h. Substituting r equals to 5 and h equals to 25 centimeter, we have 31.4 into 30, which is 942 square centimeter or centimeter square. To find the curved surface area, we will only use 2 pi rh, and the value of pi is taken as 3.14. So we have 785 centimeters square. Let us see how to find volume of a cube, cuboid and cylinder. For a cube, it is nothing but a cube. So if a is 3 centimeter, we have 3 cube, which is 27 centimeter cube. To find volume of cuboid, we multiply the length, breadth and height. So for the length, breadth and height, 5 centimeter, 3 centimeter, 2 centimeter respectively, we'll multiply and we'll get 30 centimeter cube. Let us see how to find the volume of a cylinder. It is nothing but pi r square h. If r is 5 centimeter, height is 21 centimeter, substituting these values, here we have put the value of pi is 22 by 7, or we can take it as 3.14. So we get 1650 centimeter cube. Now, if you want to express volume in liters, for example, what is the volume of water capacity for this cylinder? So you cannot express it in meter cube or centimeter cube. For that, you have to convert it into liters or milliliters and so on. So 1 meter cube is nothing but 1000 liters, whereas 1 centimeter cube is 0.001 liters. Let us see some tricks for the exams. While dividing algebraic expressions, you have to take care of the sign of the product. The product of two terms with same sign will be positive, and with different signs it will be negative. So if you are multiplying two terms having same sign, means if it is 3ab into 3ab, so the product will be 9a square b square. But if it is 3ab into minus 3ab, means having two different signs, then it will be minus 9a square b square. Similarly, when you're dividing a polynomial, we need to divide each polynomial or each term of one polynomial by each term of the other polynomial. Always while dividing algebraic terms, remember that we need to divide the constants and subtract the powers of the variables. So here if you have 15 x to the power 5y divided by 3x square y, then what are we going to do? We are dividing the constant. So 15 divided by 3 is nothing but 5, as 5 3s are 15. Whereas here you can see x raised to 5 x square. What are the powers here? 5 and 2. If we subtract 5 minus 2, we'll get 3. Whereas the common term here is y. So you can cancel out y. So here we get 5x cube. Now you have to remember these identities because they will be helpful in factorizing algebraic expressions. What is a plus b square? It is nothing but a square plus 2ab plus b square. A minus b square is a square minus 2ab plus b square. A square minus b square is a plus b into a minus b. X plus a into x plus b is nothing but x square plus a plus b into x plus ab. let us see how to check the accuracy of factorization. After factorization, you have to multiply the factors and check whether you get the original expression. For example, let us factorize this. How will you do? You will split the middle terms, which is minus 14k, such that once you split, you can regroup them and you can find out the common factors by regrouping them into pairs of two terms. So here you can see k square minus 14k is split as minus 16 plus 2k. Then we have grouped k square minus 16k and 2k minus 32. So if you place a bracket here like this, you will see there are two terms in each bracket. And then you are taking out the common. Here k square is k into k minus 16 into k. You can see only k is common. So take it out of the bracket. So we have k minus 16. Here you can see it is 2k, means 2 into k minus 2 into 16. So we have 2 common. Note that these two brackets should be having same term. So we have k minus 16, we'll write it once. Then we have k plus 2. So we'll have k plus 2. Now you want to check whether this factorization is the correct one. So what you are going to do, you will cross check by multiplying the factors and checking whether you are getting the original expression. So let us multiply k plus 2 and k minus 16. So each term of this bracket should be multiplied to each and every term of this bracket. For that, what we are going to do, we'll take k and multiply it with k minus 16. Then we'll take 2 and then we'll multiply it with k minus 16. In this way, we'll get k square, k into k is k square, k into 16 is minus 16k, 2 into k is 2k, and 2 into 16 is 32. And you should take care of the signs here. You know, minus 16k plus 2k is nothing but minus 14k, which is our original expression. So this is nothing but our original expression. So this is one trick to check whether you have factorized correctly or not. Let us remember while factorizing an algebraic expression using this identity. Here the students usually get confused. Here you can see a plus b into x is positive. The term a into b is positive. So the factors will be x plus a, x plus b. But if the term a plus b into x is negative, term a into b is positive, then the factors will be x minus a, x minus b. That is x square minus a plus b into x plus ab, which will be equal to x minus a, x minus b. So the thing to remember is whenever you are having minus sign, here x square minus a plus b into x plus ab, you have to take here minus sign, or conversely, you can take x minus a into x minus b equals to x square minus a plus b into x plus ab. But if a plus b into x is positive and ab is negative, then the factors will be x minus a, x minus b, or x minus a into x plus b. That is, if you have minus here, then it can be this one or this one. You should not get confused between perimeter and area of a circle while you are dealing with the chapter mensuration. Perimeter is the boundary of figure, whereas area is the amount of surface occupied by the shape. For perimeter, what we are doing, we are adding the lengths of all the sides of the figure. For example, if you remember how we found the area of a square and perimeter of a square. Perimeter is found by adding all the sides of square. Whereas to find the area of the shape, we apply the correct formula. To identify the different shapes that form a given shape. For example, the shape above is made up of two semicircles. So this is one semicircle, this is the other one. And you can see here it is a rectangle. So the total area of the shape will be the sum of the areas of the semicircles and the rectangle. Also, you should not get confused between the surface area and the volume of a 3D shape. Surface area we find for 3D shapes and volume also we find for 3D shapes only. But surface area is found by the area of each face of the solid shape. We'll take the sum of all the areas of each face of the solid shape, whereas the volume of solid will be the amount of space it occupies. So we have to remember the formula to calculate the surface area and also to find the volume of each solid. Now, students often get confused between total surface area and lateral surface area. Total surface area is nothing but area of all the faces of solid, which include area of bases also and lateral surface also, means walls of the solid. And for lateral surface, it is the area of only the walls of the solid, and we avoid the bases. For example, for the cylinder, we saw how we are avoiding the bases, which are circular in shape, and we are finding only the area of the curvy surface, which we can cut and we can see it is a rectangle. For example, in a cube, the lateral surfaces are the four walls of the cube. So as I told you, the top face and the bottom face of a cube are avoided there. Also for cylinder, we are finding the area of the curved surface and we are avoiding the top and the below bases of that cylinder, which are circular in shapes. Also, to identify the context where you must find the lateral surface area and total surface area, there are some contexts. So whenever you are dealing with painting the walls of a room, you will find lateral surface area because you have nothing to do with the base, that is the floor of that room or the ceiling of that room. You are only focused on the walls of the room. Cementing a cylindrical well. For well also, if you can see, the top surface is nothing but open and the bottom surface is nothing but the water surface. When you are cementing, you are only considering it's the cylindrical surface of the curved surface of the well. So here we are using lateral surface area. Next is the area covered by a revolution of a cylindrical road roller. So for a cylindrical road roller, only we are considering the surface of the roller and we have nothing to do with the bases of that roller. And whenever you're considering the area of metal sheet that needs to be rolled into a cylinder of a certain height and radius, for that context also we use lateral surface area. And while dealing with total surface area, so if you want to find metal sheet needed to make a closed cylindrical tank, then you will use total surface area. Or when you are cementing the four walls, the floor also and the ceiling of the room also, then you have to use total surface area. And if you want to find the amount of cloth or material needed to cover objects like a box or suitcase, etc. For example, whenever you are wrapping a gift using a gift paper, that time also you are using a total surface area. In the chapter mensuration, you have to take care of the unit, especially when you are dealing with the length, perimeter, area, or volume. You have to remember the unit of length will be in centimeter, meter, kilometer. Unit of perimeter will also be in centimeter, meter, kilometer. There will be no square centimeter, no square meter, no square kilometer, or cubic centimeter or meter cube, and so on. While dealing with area, you will have centimeter square, meter square as the units of area. And for volume, you will have centimeter cube, meter cube, and so on. Let us see what are the some common mistakes a student can do when they're dealing with these two chapters. One is writing, first one is writing one as a factor. For example, whenever you are factorizing 3pq plus 3p. So 3pq is nothing but 3 times p into q, 3p is 3 into p. We see that 3 and p is common in the two terms of the expression, but in the first term q remains, but in the second term there is no factor other than 1 which is remaining. So it's necessary to write 1 as a factor on the second term. Otherwise, what students will see, they'll see that for the two terms 3p and 3p is common, but here in the second term nothing is left. Nothing is left means there is one factor left, which is 1. So here you can see how a student has done wrongly in the second method. He has taken 3p as common, and in the bracket for first term he has taken q, but for the second bracket the child thinks there is nothing common, so can write 0, but this is not correct. For factorizing algebraic expression, when there are 3 terms, you can factorize by taking common factor out only if the 3 have a common factor. Otherwise, you have to check whether you have to use any identity or you have to split the middle term and then take the common factors out. So, for example, here you can see you have t square plus 4t plus 4. The first term and the last term are perfect square, means 4 is a square of 2, whereas 40 can be written as 2 into 2 into t. So we can either apply the identity a plus b square or a minus b square. Since here there are no minus sign, you have to apply this identity. As I told you, t square plus 40 plus 4 can be written as t square plus 2 into t plus 2 square. That's why we have 40 equal to 2 into 2, which is t plus 2 square. So this is the correct way of doing. For factorization of algebraic expression of the form ax square plus bx plus c, we can split the middle term and we can find the factors of the product of the last term and the first term such that their sum is the middle term. Let us understand this using one example. Here we have p square plus 6p plus 5. So let us split this term 6p into two terms such that after grouping we'll get some common factors among two terms and some common factors among the other two terms. Here you can see the common factor is p. In the bracket we'll have p plus 5. Here we have plus 1. In the bracket we'll have p plus 5. As these two brackets are same, so we have p plus 5 into p plus 1. And here the child has done 2p plus 3p. Here you can see 2p plus 3p is not 6p. So the trick here is you have to write or you have to split 6p such that if you multiply these two or the constants, you will get the constant term as the last term. So here we have 3 2s are 6, but here we have the term 5. So you can see 5 into 1 is 5 and 5 plus 1 is 6. Let us see finding the value of expressions. When we substitute negative numbers in the powers of variables, we should be careful about the sign. For example, if you want to find the value of 2x to the power 4 plus x cube minus 3x at x equals to minus 1. So you'll have 2 into minus 1 raised to 4 plus minus 1 raised to 3 minus 3 into minus 1. So you have to take care whenever you are taking the even power of negative number, then you will get negative number or you will get positive number. Whenever a negative power is raised to even power, will get a positive number or will take it as positive. When we are taking odd power of negative number, we'll get negative number. So here you can see minus 1 cube is minus 1 and minus into minus will be plus. So this is the correct method of evaluating this expression. Let us see relation between volume and capacity. Volume is the total space occupied by an object and it is measured in cubic units. Whereas capacity refers to the maximum measure of an object's ability to hold a substance like a solid, liquid or gas. Capacity can be measured in almost every other unit, including liters, gallons, pounds, etc. Now, let us see conversion of units. If a water tank is in the form of a cylinder whose radius is 1.5 meter and the length is 7 meter, we have to find the quantity of water in liters that can be stored in the tank. Let us see what are the students' responses for this word problem. So response 1 is the student will find the volume of cylindrical tank by using the formula pi r square h and he will get the conversion meter cube into liters as 4950 liters. Let us see second response. A child does pi r square h by taking the value of pi 22 by 7 into the radius 1.5 into 1.5 into 7, 49.5 meters cube. Converted into liters, the child has 49,500 liters. So what is the difference between these two answers? Here we have pi r square h 49.5 meter cube. So here the meter cube conversion, how it is taken? 1 meter cube is taken as 100 liters, whereas in the second response it is taken as 1000 liters. So here the difference of 10 is important. So 1 meter cube is taken as 1000 liters and this is the correct response. So you have to remember these relations properly. Let us see how to find area of a trapezium. We'll observe one example here. The area of a trapezium is given by two responses. Let us see the two responses given by two kids. The first kid says the area of a trapezium is half into 5 plus 6.5 into 6. What he has done is taken 5 means the addition of the non-parallel sides and the height 6 centimeter. But note that the area of trapezium is half into sum of the parallel sides. Are these parallel sides? Sides measuring 5 centimeter and 6.5 centimeter? No. The parallel sides are 4.2 and 8.8. So you have to add 4.2 and 8.8 and not 5 and 6.5. So this is the correct response by a student. Let us see why response 1 is wrong. Yes, as I told you, sum of parallel sides should be taken. and then it should be multiplied by height. For area of a polygon, we split the quadrilateral into triangles and find its area. Similarly, we can use it to find the area of any polygon. For example, you can observe one hexagon here. We have to divide the hexagon into parts, means you can divide it into triangle, trapezium or rectangle and find out its area. Let us see what are the responses by students. So response 1 is a student has splitted it into a rectangle MOPR, two triangles NMO and RQP. And the dimensions are, you can see the distance between the vertices N and Q is 11 centimeter. Distance between OP is 5 centimeter. Whereas distance between RP is 8 centimeter. How we have found this? It is already given. So if we cut the hexagon into three shapes, two congruent triangles and a rectangle, the total area will be the sum of the areas of these two triangles and the rectangle. But in the response to given by a child, you can see the child has divided the hexagon into two parts, and these two parts are trapeziums. So what are the parallel sides of the trapezium? M and QR, it will be MR and NQ, and NQ and OP for trapezium, NOPQ. What will be the heights? As it is given, RP equals to 8 centimeter. So height will be 4 and 4, correct? So this is also the correct approach. And then we'll be able to find the area by adding the area of these two shapes. Let us see what is the response 3 by a student. He has joined the vertices N and R and found one triangle. And this triangle has height and a base, but the height cannot be determined. Also, the base cannot be determined. So this is a wrong approach. Let us see what is the difference between lateral surface area and the total surface area. For the shapes like cube, cuboid, cylinder, we calculate lateral surface and total surface, but they are not the same. You can see for the lateral surface area, we are excluding the areas of the top and the base surfaces. So these two surfaces are ignored. So in cuboid, we use lateral surface area, whereas in case of cylinder, it's curved surface area, which we exclude its top and base surfaces. Whereas the total surface area is the area of all the sides of three-dimensional figure. So we include here the circular shapes as well. So this is total surface area of a cylinder. Let's say if you have to paint the walls of a room excluding the floor and the ceiling. In this case, will you use lateral surface area or total surface area? Note that you have nothing to do with the floor and the ceiling. You are only painting the walls of a room. So we have to find the curved surface area of the room. Let's say if we have to calculate the size of the label to be put around the curved surface of cylindrical can. In this situation, we calculate the curved surface area of the cylinder. For example, here you can see the label of mac and cheese has been put into the can. So here we have nothing to do with the top and the base surface. So in this case, we are using the lateral surface area, not the total surface area. One more example we'll see. If you want to gift wrap the cuboidal box with a paper, and then you have to, for this you have to calculate the amount of paper. So you need to calculate its total surface area, not lateral surface area. For example, you can see a cuboidal box here. So for this box, if you want to wrap some paper, then you have to find the total surface area. Because you have to consider the top and the bottom bases as well. Let us see what is the difference between surface area and volume. Volume is a space occupied by three-dimensional space. Suppose there is a hollow bottle. So to find the volume, it is nothing but the quantity of the liquid it can hold. So volume of the bottle is equal to the quantity of the liquid. Whereas for surface area, it is the sum of the areas of all the faces. Finding surface area of solid is finding like how much paper we need to wrap to cover a solid or the area of the outside faces of the box. It is measured in square units, whereas the volume is measured in cubic units. Let us see what are some exam tips for these two chapters. First is you have to variety of questions to be practiced from NCERT textbooks, exemplar and other textbooks, and also from previous year question papers. You have to note down all the definitions and identities separately. You have to draw relevant figures to represent the question. For example, whenever you are splitting a polygon into triangles or trapezium to find its area, then you have to draw relevant images so as to properly you can use the formula. You should avoid calculation mistakes while you are dealing with algebraic expressions. You have to express your answer in the correct unit. You have to read the question carefully and understand it, whether you have to find total surface area or curved surface area, lateral surface area, the volume or the surface area, and so on. While solving word problems, you have to write down what is asked and what you have to find. And at the last, you have to check whether you have answered all the questions and parts of the questions. I hope this session was helpful. And if you want to quickly revise the concepts, practice some more sums, and also take a quick test, then Countingwell exam prep kit is here. It will let you quickly glance through the major concepts of your chapter. You can also glance through the solved examples. You can practice variety of practice questions and chapter assessments. You will also understand the tips and tricks, common errors that you can make, etc. Over 75,000 students trust Countingwell for their math learning, and even without the exam prep kit, they can learn every day on the app by diving deep into every chapter. You can download the app from the App Store or Play Store. So stay connected to our channel Countingwell and learn more tricks and tips and ways to avoid common mistakes. We will be revising the chapters comparing quantities, direct and inverse proportion from class 8 in our next live session tomorrow on 15th February at 6:30 p.m. Well, see you in the next session. Until then, keep learning, keep growing. Thank you.